Hey everyone, welcome back to my number sense series. In this video, we're going to talk about perhaps one of the most important things we will ever talk about in this series, which is the difference of squares. Now, if you don't know, the difference of squares is an identity. It's an algebraic identity just like FOIL, but we can use it in so many ways to simplify our multiplication. So here is the difference of squares. As the name suggests, it is a difference of squares. A squared minus b squared, that's the difference, right? So what the difference of squares identity says is that a squared minus b squared equals a plus b times a minus b. And we can actually verify this with FOIL, so I will do that real quick just to show you what it looks like. If we FOIL this out, we will get a squared plus b times a minus a times b minus b squared. And you can see plus a times b minus a times b, that will cancel out, and all we'll have is a squared minus b squared. But how does that actually help us with multiplication? Well, normally instead of going from this equation to this equation, we actually like to take two numbers, when multiplying two numbers, we like to express them in the form of a plus b times a minus b, so that we can then say it's actually a difference of squares. And if that doesn't make much sense, that's totally alright, because I will show you how that looks right now. So 19 times 21. These numbers aren't too big, so you could absolutely do this with FOIL, and it wouldn't be too bad, but there is a much better way, right? That way is the difference of squares. So how can we transform 19 times 21 to look like a plus b times a minus b? In other words, 19 is a minus b, and 21 is a plus b. So what are a and b? So I'll just write this out right now. 19 equals a minus b, because once again, a minus b is a smaller number, and 19 is a smaller number, so we say 19 equals a minus b, and 21 equals a plus b. So how can we solve for a and b? Well, if you're not so familiar with solving systems of equations, that's all right. But what we're going to do is we're going to add these two equations together, so we get 40 equals 2a. So that means a equals 20, and b equals 1, because when you plug in a equals 20, we get 19 equals 20 minus b, so b equals 1. In other words, how do we get a, right? We added 19 and 21 together, and then we divided by 2. What does that sound like? A is the average of the two numbers, right? When we add two numbers together and we divide the result by 2, what we are getting is the average of the numbers. So a is the average, and b is just the distance from one of the numbers to the average. And because the average is right between those two numbers, the distance will be the same, right? The distance from 19 to 20 is 1, but the distance from 20 to 21 is also 1. So it doesn't really matter how we compute b, just that we choose one of the numbers and look at the difference between that and the average. So that's how we would get a and b, right? Essentially, a is the number that's right between the two numbers that we're trying to multiply. What's right between 19 and 21? Well, it's 20. And then b is the difference between a and one of the numbers. So after all that, we can rewrite 19 times 21 as 20 minus 1 times 20 plus 1. And now we see that we can apply the difference of squares, right? A plus b times a minus b, or sorry, here it would be a minus b times a plus b the way I've written it, but it is the same thing. So we have, this is equal to a squared minus b squared, which is 20 squared minus 1 squared, right? And this is a very easy calculation, because 20 is an easy number to square, right? It's just 400. 400 minus 1 is just 399. And so I did show a lot of work here, but once you start getting in the rhythm of this step is very easy. You don't even have to write this down. So when you get used to doing this trick, what you're going to do is look at this and go, okay, that's 20 squared minus 1 squared. And then that is really easy, way easier than like trying to FOIL out 19 times 21, right? Yeah. So let's do the next example. 48 times 52. Of course, we know we're going to use difference of squares here, but how do we know we should use this difference of squares? Well, essentially, whenever these two add up to something nice, those two numbers add up to maybe like a multiple of 10 or like a multiple of 5, you know that we should probably use difference of squares, because multiples of 10 and multiples of 5 are easy to square. And what we're looking for is, easy calculations. For example, 48 and 52, what's their average? Their average is like 50, and 50 is a very nice number to square. So, that's what we're going to do. 48 times 52, that's, once again, I'm going to write it as 50 minus 2 times 50 plus 2. And so what does that give us? That's 50 squared minus 2 squared, which is 2,500 minus 4, which is 2496. And that's 48 times 52. Now, the next problem is a little bit harder, but it's not so hard as long as you remember one trick that we have already learned. 72 times 78. Now, what I just said about a minute ago. We look for difference of squares when the average of the numbers is like a multiple of 10 or a multiple of 5. Well, what's the average of 72 and 78? What's right between 72 and 78? It's going to be 75. And 75 we know how to square because we know a trick for squaring numbers that end in 5. So we're going to say 72 is 75 minus 3, and then times 75 plus 3. So then we get 75 squared minus 3 squared. So what is 75 squared? Just do it in our heads. That's 5625, right? And what's 3 squared? That's 9. So our answer is 5616. And once again, once you're very familiar with this trick, it should be pretty easy to just go from here directly to here, because of course that is the goal of number sense, right? So our last example that's going to look exactly like this is going to use some bigger numbers. But again, the bigger the numbers are, the easier it is to recognize the pattern. Because we have 197 times 203, right? I mean, what else could you possibly use other than difference of squares? Like noticing that you have 197 and 203, and what's right between them? Well, 200 is right between them. So of course it's going to be difference of squares, right? 200 is such a nice number. So let's actually skip this step right now. Let's try to do it in our heads. What is it? What is it? Well, if you said 200 squared minus 3 squared, you would be correct because 197 is 200 minus 3 and 203 is 200 plus 3. So we're going to have 200 squared minus 3 squared. Now what is that? That's 40,000 minus 9, which is going to be 39991. Now, our second to last example is actually going to be going in the other direction, right? Normally we go from right to left on this, but here, well, they're basically telling us what to do, right? They're telling us this, well, this is a difference of squares, so we should use this to simplify our calculation. We should go from left to right. So this is a squared minus b squared, right? A squared minus b squared equals a plus b times a minus b. So this is going to be 58 plus 42 times 58 minus 42. And what's nice about this is that 58 plus 42, that's 100. 100 times 16. 100 is so nice to multiply by. So, when we see this, we should absolutely think difference of squares. So, of course, 100 times 16 is just 1600 or 1600. That's our answer. Now, last example is going to be something very similar to these. And this time we have an even nicer number to square, right? When we see this, we should think, okay, 94 and 106, those numbers are right around 100, right? Instead of using the trick that we do with 90a times 100b, that can be a little bit hard, what we can do here is just say, wait, those are the same distance from 100. We can use difference of squares, right? 94 times 106, that's 100 squared minus 6 squared. So I'm not going to write it out this time, so hopefully you guys can understand. 94 times 106 is 100 squared minus 6 squared, right? So it's 10000 minus 36. Really try to do this in your head, but you can use scratch paper if you need. That's going to be 9964. And that's it. So I would say the hardest part of difference of squares is really just like the computation itself, right? As you gather experience with this, it will become increasingly obvious which questions you should use difference of squares on, and those questions that you can use difference of squares on, it's going to make them so much easier. So I really hope you guys understand this. Definitely go back and rewatch if you haven't, because this is super important, and I'll see you guys in the next video. Thanks for watching.